Good afternoon, everyone. How are you all? I hope you all are good, enjoying your life in Navodayas, I hope. And I hope you have revised the previous class. What we have discussed already in this chapter, we have discussed magnetic flux. We have discussed already about EMI, what is electromagnetic induction. We have already discussed that part. We have discussed Lenz law. So now in this particular lecture, what we are going to do, first of all, we will do some recall test questions. After that, I will move towards self-induction and mutual induction. This is going to be the last lecture of this chapter. So on this note, first of all, I have given you a homework question. So first of all, we will solve that question. After that, we will move ahead. Okay. So I hope you have completed the question. This is your question. In the previous class, we have discussed about motional EMF. The question was based on that motional EMF, and what it says there is a wheel actually which contains 10 metallic spokes. Like if I say there is a wheel, it has some 10 metallic spokes, each of zero point 0.5. Zero point 0.5 means half meter long and is rotated with a speed 120 revolution per minute. So let's suppose it has 10 spokes. So I am just drawing few of them. I am not going to draw all those 10 spokes. For simplicity, I am just drawing. Let's suppose I am drawing one spoke, two. Similarly, you can draw three, four, five, six. So I am not counting the numbers, whether it is 10 or whatever it is. But let's suppose this is a wheel which contains some spokes. So what it says that wheel is rotating with some angular velocity. Let's suppose its angular velocity is omega. Can you see that when this wheel is rotating about its axle, this is the axle, then each of the rod is rotating and some sort of EMF will be developed in each of the rod or each of the spoke, clear? And magnetic field was given as 4 Tesla at that place. Okay. So first of all, we will collect the data, what it was. First of all, angular velocity is omega is equals to 120 revolution per minute. RPM means revolution per minute. Is it so? So you need to convert it in radians per second. And if I do that, radians per second, what it will become? Omega is equals to 120. Revolution means 2 pi radians divided by minute can be converted into second like 60 seconds. So you can say that this is going to be 2, that is 4 pi. I hope it is clear. 2 into 2, 4 pi. So omega is mentioned as 4 pi. What is the EMF developed in one spoke? So I will write EMF induced in one spoke. You will say E is equals to half B omega L square. I hope you remember this relation. Half B omega L square, just put the values and you will see that E is equals to half. Magnetic field is 4 Tesla. Omega is 4 pi. And L square, L is what? Half meter. 0.5 meter means 1 by 2 meter as well. Half meter. And if you square it, it will become 1 by 4. Clear? So it can be cancelled out here. 4 and 4 can be cancelled. 2 and 2. So EMF induced will be 2 pi. This is the EMF induced in one spoke. Now the question, which is very simple, let's suppose this is the magnetic field. So this, for example, I'm talking about this rod. So this end will become positive, this end will become negative. Using Fleming's right hand rule, you can identify the positive and negative terminals of the rod. Now, similar thing will happen with all the rods. Can you see that? All the rods are rotating in the same direction. So all such rods will develop same EMF. That means 2 pi EMF will be developed across each rod. So each rod will behave as a cell of EMF 2 pi volt. Now, what the simple thing is, if each cell is behaving like that, you have to calculate the total potential between the axle and the rim of the wheel. So total potential will be the combinational sum, and combinational sum, you can see all these cells are combined in parallel. And remember one punchline from current electricity: if n identical cells are connected in parallel, then their equivalent EMF is what? Is same as the EMF of one cell. So what you can write, for 10 spokes, it is not going to be 10 times of E. It is just E equivalent is equals to E. Why? Because of this parallel combination. Because of this parallel combination. So E equivalent is going to be 2 pi. And if you put the value of pi, that is going to be 3.14 into 2. It is 6.28 volt. And 6.28 volt, if I talk about, it is our option number A, which is correct answer. So I hope you have completed that question. On this note, I am moving further for the next part of our session, which is recall test. Okay. So I will give you some 30, 40 seconds to solve the question. Okay. You have 30 seconds to solve this question. Now, the question says a coil having 500 square loops, 500 square loops of side 10 centimeter is placed normal to the magnetic field. That means flux will be maximum, which increases at a rate. Now, magnetic field is increasing at a rate 1 Tesla per second. The induced EMF is. So, whenever you see a term induced EMF, so induced EMF is d phi over dt. Is it clear? D phi over dt means rate of change of flux. I have not used a negative sign because negative sign just tells us the direction of the positive and negative terminal of the induced EMF. So we are not interested in that. So I am skipping this negative sign. So what you can write, E is equals to d over dt. Phi is what? V into A cos theta. Now you can clearly see that coil is placed normal to the magnetic field. That means theta is going to be 0 and cos 0 is going to be 1. So there is no need to write about it. So E can be written as A dB over dt. Now, one thing that you can see here, if you can see the flux, for one loop, the flux is BA. For how many loops are there? You can see 500, or you can say n loops are there. So total EMF is n times d phi over dt. What is n? N is the number of turns. So you can multiply n as well. So n a dB over dt. Now put the values. N is 500. Area you can calculate the side as 10 centimeter. So if side is 10 centimeter, area will be 100 into 10 raised to the power minus 4 into dB over dt. Rate of change of magnetic field is given as 1 Tesla per second. That is 1. So you can see that 10 to power minus 4 and these 4 zeros are cancelled. So it comes out to be 5 volt. Very simple. Very good. Moving further. Another question. You again have 30 seconds to answer the question. This question was asked in 2018 mains examination I am talking about. Now suppose, have a look. Let's suppose this is the coil. This coil is, I am supposing, assuming that this coil is placed in the YZ plane. Clear? And the magnetic field is along the x-axis. Clear? Now, you can tell me one thing. What is the angle between area vector and magnetic field? What is the angle between area vector and magnetic field? And everybody can see that area vector is always perpendicular. So if area vector is perpendicular, that means you can see that area vector is going to be in this direction. That means angle is going to be 0. Initially, I am saying that at t equals to 0, angle is going to be 0. I'm assuming nothing is mentioned in the question. So I can take anything, any situation I can start with. Sorry. Now, they are saying the coil is rotated with angular velocity omega. If coil is being rotated with some angular velocity omega, you can see my hand gestures. What I'm saying, like this is the coil. This is the coil in the YZ plane. Can you see my hand? This is going to be the area vector. Then in time t, it is rotated with some angular velocity omega. Then in time t, how much angle it can be rotated? Or it can rotate how much by how much angle? You can say that its angle rotated in time t will be omega t. Is it clear? Angle rotated will be omega t. So if coil rotates an angle omega t, then the normal will also rotate by the same angle. And you can clearly say that or state that at time t, EMF induced, or before calculating EMF, you can write flux linked with coil. How much flux will be linked? You can say phi is equals to, what is the formula for magnetic flux? Anybody knows the formula of magnetic flux? Is it B dot A, vector B dot A? So this is going to be V A cos theta. Is it clear? Now you can put the values of B and A. Phi is equals to B. How many turns are there? You can say n turns are there. So you can multiply with the n turns. If I calculate total flux, A is the area, cos how much angle it will rotate. It will rotate by some angle. I have already discussed by some angle omega t. Okay. So few of the new students has joined the session. Is everything visible to you? Am I audible to everyone? Okay. Joy boy. Okay. Moving further. Now this is the magnetic flux. Anybody knows that what is the EMF induced? They are asking the maximum EMF. Now I will describe the question. You just focus at me, look at me. What's happening? What question says there is a coil. There is a coil of some n turns, and this coil is being rotated in a magnetic field with some angular velocity omega. Now you need to calculate the maximum EMF induced in this coil. This is the simple question. So everybody knows EMF induced will be minus d phi over dt. Is it clear? Or if I put the values of minus d over dt, what is phi? Phi is NBA cos omega t. I hope everybody can differentiate this term. And if you differentiate, what you will get EMF is equals to minus is already there, NBA are constant. And if you differentiate cos omega t, what it will become? Sine omega t of minus, that is negative, and negative can be cancelled. And if you differentiate it again using chain rule, then omega will come out. So what is the EMF? NBA omega sine omega t. Let's suppose this is equation number one. They are not asking the EMF. They are asking the maximum EMF. So can you see that EMF depends on this term sine omega t? Or you will say EMF will be maximum when sine omega t is maximum. Is this statement clear? EMF will be maximum when this EMF will be maximum when sine omega t will be maximum. And what is the maximum value of sine omega t? What is the maximum value of sine omega t? Everybody knows, I hope. Maximum value of sine theta is what? Everybody knows. What is the maximum value of sine theta? It's 1. Maximum value of sine theta is what? 1. So put sine omega t as 1 and you will get E is equals to NB A omega. So this is your final answer, the maximum EMF produced or induced in the coil. I hope this is clear to everyone. Moving further. Now our next concept of this chapter is self-induction. Before moving to this part of the chapter, I just want to make sure that you have completed this chapter in the schools, or you know something about Lenz law, something about EMF, something about induced EMF, what is electromagnetic induction. Just say yes, sir, so that I can move further with some confidence about the class. If you know something about electromagnetic induction, something about Lenz law, then you can say yes, sir. Otherwise, you can also say no, sir. Then I will plan something out of that. Okay, so I'm assuming that everybody knows some basic things about self-induction, about electromagnetic induction as well. Now, what is self-induction? Look at that. Self-induction, or first of all, induction is the process of inducing EMF in a coil by changing the magnetic flux linked with it. Now, what is self-induction? Self-induction is the process of inducing EMF in a coil by changing the flux in the same coil, or by changing the current in the same coil. If the definition is not completely audible, you can read it out here. What it says, the process of inducing EMF. It is a simple definition, not mentioned many times in the books. In a coil by changing the current in the same coil. And this process is called self-induction. Now, in terms of diagram, what you can see, look at that. What you can see, this is some sort of solenoid, clear? And a circuit is attached with it with some rheostat. This is a rheostat. Now, by sliding this position, you can change the current in the circuit. And by changing the current in the circuit, current is changed in the circuit, then field will also change. Can you see this is the magnetic field? This is the magnetic field. Now, if this magnetic field changes, then magnetic flux will also change because phi is equals to what? BA or B dot A, you can say. So, flux will also change. This change in flux will create some EMF, which is known as self-induced EMF. I hope the concept is clear. What is self-induction? Now, some basic terminologies that are very useful to us. I will go there one by one. First is, what is self-induction and what is self-inductance? We have seen one thing, that EMF is induced whenever flux is changing. Now you can see, you can notice one or two things here. Do you know that phi is proportional to magnetic field? I hope everybody knows this thing. And if you look at the previous slide, look at this diagram, this magnetic field is proportional to the current. So I am writing the same statement, that magnetic field is proportional to the current. Flux is proportional to magnetic field is proportional to current. So can you combine these two and make a conclusion out of it, like flux is proportional to the current? And if you remove this sign of proportionality, phi is equals to Li, where this L is something very special and is known as coefficient of self-inductance. Or this L can be written as, from the same equation, L can be written as phi over I. Make this golden equation, because most of the times questions comes like, what will be the self-inductance of this system? They will give you a system and they will ask you what will be the self-inductance. So you need to be aware about that self-inductance. Unit, if I say what will be the unit of self-inductance, anybody remembers the unit? Or anybody who can calculate the unit, who can find the unit of this self-inductance from the equation, or if you remember, anyone? Okay, no problem. This unit is Henry, denoted by capital H. So unit of self-inductance L is Henry. And this self-inductance is a quantity which depends on the geometry of the body or geometry of the coil. What I am saying, try to remember this thing again, depends on geometry. What is the meaning of geometry? Like suppose I am talking about the solenoid. So what is the geometry in that solenoid? That what is its area of cross section? What is its length? How many turns are there? So these are the geometries of the coil. So it depends on the geometry of coil or solenoid, whatever it is, whatever the element they are using, but it is going to be a dependent quantity on the geometry. Geometry means, I hope everybody knows the geometry means area, length, number of turns, etc. I hope this is clear till now. Moving further. Now, one more thing that you should know, if this is the phi or flux linked with a coil, in this equation, one thing to be noticed, for self-induction, this current I must be variable. Can you see that? If this current is not variable or if this is constant, then flux will not change. And if flux will not change, no EMF will induce. So this I will be variable. Keep in mind, this I is variable. So what is the EMF induced? What will be the EMF induced? You know that E is equals to minus d phi over dt. Okay, I'm again asking, just confirm one thing. Have you completed this electromagnetic induction chapter, or have you started this chapter in your schools? Depending on that, I will move ahead. Whereas it will be very difficult if you will not speak out a single word, or if you can't message a single word. It will be difficult for me to understand. Now put the values of phi. Phi is what? Li. L is a constant, so E will become minus L di over dt. What does it signify? This is going to be the self-induced EMF, the golden equation. Self-induced EMF. Are you guys for real? Can't you type a message by saying completed this chapter, saying yes sir, no sir? What kind of response I am asking you? Not much I am demanding from you. Just simple thing I am asking you. Harshit Lal is saying yes, sir. Very good, Harshit. Try to be interactive so that I can feel like you are getting something completed. Everyone is saying completed. Very good. Devdutt is saying, Swati is saying completed. Now that's really good. Now I can move further with some confidence. Okay, coming back to the topic. Can I ask you a simple question? Can I ask you a simple question from Lange law before moving to our? I hope everyone will answer and it will make us more interactive towards each other. Okay, very simple question I'm asking. Let's suppose this is a long wire, clear, and it has some current I which is constant. This is a square loop. Let's suppose this is loop number one and this is two. This loop is moving in this direction and second loop is moving in upward direction. So you need to tell me what will be the directions of induced current, clockwise or anti-clockwise. First of all, or write in the manner of sequence of 1 and 2. Like what will be the direction of induced current in first loop and what will be the direction of induced current in second loop. This is long wire. Current is constant. What will be the direction of induced current in loop 1 and in loop 2 respectively? You need to answer. Anyone? 4 seconds. Outward for 1. Question is find direction of induced current. Direction of induced current I am asking. So current will be either clockwise or anti-clockwise in the loop. This is the motion of the loop. Like in this direction, block is moving or the loop is moving. If I name a few persons, Harshit, Pooja, Roshna, Joy Boy, Devdutt. Harshit is saying clockwise for 2. Okay, and what about 1? Other persons, Devdutt, Joy Boy. Okay, now I am describing. Devdutt is saying clockwise for 1. And what about 2? Okay. Now, listen. First of all, I will discuss about 2 and then I will discuss about 1. What is the one thing which is necessary for the EMF to induce or the current to be induced? The change in flux. Is it clear? The flux must change. If you look at that, can you see that if I talk about the loop 2, this is the loop 2. If I talk about this loop, the perpendicular distance from the wire, this is the perpendicular distance of this side and this is the perpendicular of distance of this side. If this loop is moving parallel to the wire, then this perpendicular distance will remain constant. And if perpendicular distance remain constant, that means magnetic field will also remain constant. I hope you remember the formula of magnetic field, first of all. So if magnetic field remain constant, That means flux is constant and no current will induce. This is what it is mentioned. This is no current, no current. That means in loop 1, there is no current. Zero current will induce. Sorry, in loop, I'm saying. But what I'm talking about loop, it will have zero current. Now, if I talk about first loop, this is first loop. Now, you can clearly see that this loop is moving away from the wire. If loop is moving away from the wire, you can see the horizontal field is H direction and horizontal field is horizontal field is this field is moving. Horizontal field is so the net the impedance it supports this new field or induced field should also be in the that. Are you getting this? Oh, Harshit. I try to speak again. There was a network glitch. Is it now? Audible? Is audible now? I hope it is. I'm repeating. I'm saying this is moving. So new field will be set to support the and something of the field must be now what to do that induce field just just put it by the action of induced field earlier and if you put it audible now. Okay. I hope this screen is visible as well. was saying that was in the clock direction for loop 1, in the clockwise direction, and loop 2 was 0. This one is clear to everyone. Now, on this note, my screen is visible to you. Okay, I hope network issues is solved right now. Just confirm once. Okay. Thank you, Bacha, for the patience. I am deleting this question so that we can move further on the topic self-inductance of the solenoid. Okay, Joseph, you want to say something? You can type in your message. Now look at that. Let's suppose there is a solenoid. This is a solenoid. like this. The length of the solenoid is L. It has some n number of turns per unit volume. I hope everybody knows this small n. Small n means n number of turns per unit volume. And there is a current I that I have given to it. This is I, current. And I need to calculate the self-inductance of the solenoid. If you remember one thing, that self-inductance was flux linked with the coil divided by that variable current phi over I. Let's suppose this is our equation number one. This is the current, and this current will come out from here. Now, what is our task? Our task is to calculate the flux. I am doing this derivation because most of the times questions comes where they are not asking about solenoid. They will ask you about some other diagram, other coil. So you must be aware about the process. So the first step that I will do, I will try to calculate the flux linked with the coil given. So if I calculate, the flux is B into A. For that, I need to calculate the magnetic field. And one more thing, you can assume that area of the cross section is A. So magnetic field of solenoid is what? I hope everybody remembers. Can anyone answer what is the magnetic field of the solenoid? You know that mu naught n I. I hope it is clear to everyone. This current will create a magnetic field mu naught n I. Now, flux linked with the solenoid, you will say flux will be how many turns are there? You can say total n number of turns per unit volume are there. How many turns are there? N number of turns per unit volume. Sorry, per unit length. So how many total turns it will become? N into B into A. N is the total number of turns. And what are the total number of turns? You can say phi is equals to N is the turns per unit length. And what is the length of the solenoid? L. This is the total number of turns. Magnetic field is what? Mu naught n I. Area of cross section is A. So this is your total flux. You can write it as mu naught n square A L I. Is it clear? So if this is the total flux, put this value in equation 1 and you will get your answer. And what will be your answer? L is equals to I can be cancelled mu naught n square A L. This is your self-inductance. As you can see from the relation, this self-inductance depends on the number of turns, area of cross-section, and length of the coil or length of the solenoid. Out of which, if someone asks you that how you will increase the inductance, how you will increase the self-inductance of a solenoid, then the most preferable thing is to insert some iron material inside it or some soft iron material inside it. Mu naught is the permeability of free space. And if you insert some iron material inside it, the permeability increases and the self-inductance of the coil or of the solenoid increases many times. So the best way to increase the self-inductance, try to remember this thing in AC chapter, you will face such kind of question when you will find that a iron rod is inserted inside the solenoid. Then what will be the effect on the bulb? These kind of question you will see in AC chapter. So for that, you should remember that if you insert this iron rod, you will see that self-inductance will increase. I hope it is clear, and it depends on the geometry as well. It is clear till now. One more thing that I will discuss here, that what is inductor. So this current carrying solenoid is termed as inductor. This is a conducting coil and termed as inductor. This is the symbol of inductor. One thing, how much EMF will induced or self-induced EMF will induced in this inductor if a variable current is given to it. If you give it some current I which is variable, then how much EMF will induced in it? So EMF induced in this inductor will be minus, this is its self-inductance L di by dt. Now from this relation, one more punchline you can form. What is the punchline? Higher the self-inductance, more will be the EMF induced. Can you see that direct relation? Higher the self-inductance, more will be the EMF induced. So you can say that E is directly proportional to the L, self-inductance. One thing that you can say. Another thing that I will discuss here. You can see that this is the self-induced EMF. Now, one more type of question that is usually asked in this topic about inductor is something, three case I will discuss. For example, this is an inductor. This is and A, this is and B, and this is some inductance L. And a current I is flowing through it, which is constant. Some current is flowing through it, which is constant. Then what will be the induced EMF? Can anyone tell me what will be the induced EMF in that situation? If a constant current passes through it, what will be the induced EMF or self-induced EMF through this coil, through this inductor? If current is constant, that means it will not, the flux will not change. If flux will not change, it will not create any self-induced EMF. So EMF induced will be zero. You can also see it from the equation E is equals to minus L di over dt. Current is not changing, that means di over dt is zero. So EMF induced will also be zero. This is the first and simple case. Now second case, which is very interesting, that I will ask. Like again, the same inductor is there. This is the self-inductance. This is current I. This is point A. This is point B. And this current I is increasing. Then some EMF will induce in it. That's for sure. Now some EMF will induce in it. What will be the EMF of that? Everybody knows that EMF induced will be L di over dt. I am not using the negative sign. Now look at me. What will happen? This inductor will behave. Now listen to me this point very carefully. Everyone should listen. This inductor will create some EMF and will behave as a cell, such as to oppose the increasing current. The current is increasing and is moving from A to B. So it will create a cell which will send current from B to A. So it will behave like this cell, which is sending current opposite to the original. Are you getting my point? So which end will become positive? A, B will become negative. Now I am waiting for 1 or 2 seconds. Is this statement clear? How can I write this that and A will become positive and A will become negative? Is it clear to everyone? And one final case. Again, same inductor is there and A, B, some current I is moving and this current is decreasing with time. And if this current is decreasing, what will happen? Some EMF will induce in it. How much EMF will induce? You will say L di over dt. Correct. Now the current is decreasing. So this inductor will try to support this current and will behave as a cell which will support this current. So it will behave as this cell. So identical circuit you can draw. This is A, this is B, and this term will become positive, this will negative. And this is the cell. So what I am saying, what is the purpose of this slide? That an inductor can behave as a cell when current through it is changing. And the polarity of the cell you can decide using Lange law. I hope this is clear. Now on the next slide, there is a question for you. Answer this question or answer the second part first. You have 20 seconds to answer the second part. These are not the options. These are the three parts of the question. So do any one part and answer. After that, I will solve. Or most importantly, you can take the screenshot and do it in your homework. This is the previous year question asked in some exam. I have modified it a bit for simplicity and for the knowledge purpose. I have simplified it and modified it basically. So try to do it in your homework. Right now, time is over. So I am just ending the session. Bye, everyone.